Okay, so what I'd like to do today is talk about a tool that I was pointed to by one of my viewers, and I'd like to thank them. I really appreciate them pointing me to it and appreciate their viewing the videos. And the tool is called Solang. And what makes it very interesting, if you look at this, is that as you can see, you can take a Solidity source file and it creates a WASM or BPF file that can deploy on a substrate chain or an Ethereum chain. So where it's going to be really useful is people who've done a lot of Ethereum-based contracts in Solidity, which is kind of, we looked at ink for substrate. Well, Solidity is kind of the counterpart for Ethereum based change. So you have all these Ethereum contracts that you wrote. Now you want to go on a substrate-based chain like Polkadot. This is where Solang comes in. What it does is it is what they would call, I guess, a cross compiler, and I've seen them quite a bit, especially in the past with some of the earlier languages and tools where for example, I remember one place I worked, we had developers who were cross-compiling our Windows code to run on a Mac. Now, cross-compilers, I see them now mostly in trying to go to like the tiny hardware, like trying to put things on run a Linux that's running on an FPGA board, or some kind of board, microcontroller, or things of that nature. Some of the smaller, well, I don't know if you something one like the Beagle board, things of that nature. Where you would use the C cross compiler. But we have languages now, for example, Java and Python, that are very versatile in terms of you don't need to use a cross compiler. You can create something in Python on Windows and then bring it right over to a Linux box, or write Java code on a Linux box and deploy it to a Windows server, or vice versa. So it's, in terms of pure coding, they're not quite as critical anymore. But in terms of our blockchains, if you're talking about blockchains that support different smart contract, like substrate and eWASM, this is where Solang becomes very important. And Solidity is, like I said, kind of, or you could say ink is substrate's answer to Solidity. And you can see you get the same, in some ways it looks very similar to our ink code, where you are writing your contracts at a higher level, and that is, you're going to write these things, and you don't want to have to then bring them into ink or write them in Rust, a Rust contract, using the Rust contract. So this is where Solang becomes very valuable. So anyway, that's the main topic of today. But I did want to mention what's going on with this. So far, I have not been able to get the Polkadot or the substrate chain to take a contract again. So I'm trying to still figure that one out, but it's got to be something weird in my configuration, because if no one was able to do it, you'd be hearing about it all over the message boards and so on regarding Substrate and Polkadot. So we're going to continue to take a look at that, and I do at some point, I do want to give Solang a hands-on, because one word of caution regarding using things like Solang is very often you'll run into things when you actually try to use it, incompatibilities, something changed somewhere in Solidity and hasn't caught up in Solang, or things of that nature happen quite frequently. But I would like to get a hands-on this and bring it to you, because I think, well, first of all, Solidity is valuable because it's so commonly used in the Ethereum realm. And Solang is valuable, like I said, because if you have Ethereum contracts, if you've already bothered to write stuff in Solidity, you can bring it straight to Polkadot without having to rewrite the whole thing in ink or, Rust, etc. So anyway, that's going to be all for today, and hopefully this has been valuable. If it has, please give it a like. And if you want to see more, please subscribe and ring the bell to get notifications. And I will speak to you next time.